Hello students, how are you? I hope you should be fine at your home. Today we are going to discuss the properties of alkali metals. On the basis of properties of metals, metals also classified into different groups like alkali metals, alkaline earth metals, transition metals, lanthanides, actinides. On the basis of their properties, on the basis of their electronic configuration, it is divided into different groups. They have different behavior, physical and chemical properties because based on the number of valence electrons present in the atoms. So the alkali metals, it is the first member of the, that is first group of the periodic tables. On the basis of their reactivity, on the basis of their properties, almost you can say it is very highly reactive metals, and reactivity compared to other metals, it is high. They have high reactivity compared to other metals. So let us discuss some physical properties of alkali metals. Now first is discuss about the occurrence. Occurrence are their very reactive metals. They do not available in generally in normal ground state. You can say not available in the native state. They are not available in free state. They are not available in the native state because due to highly reactive nature. So not available in free state. They are not available in free state, available in oxides, halides, nitrate, carbonate, different salts, mainly available in different salts, oxides, halides, nitrate, carbonate, sulfate, phosphate, like this it is available, but not available in free state. Free state is not available, that is very important thing. And available in the different ores from in ores form, that is we can say sodium chloride, that is called common salt. It is called common salt or table salt. That sodium nitrate is called Chile saltpeter, and your potassium nitrate, Indian saltpeter, these are some names, okay. And borax Na2, B4O7, NH2, this is called borax. So these are some ores, alkali metals available in different ores. So these are the some occurrence of alkali metals. Then second properties, that is electronic configuration. Electronic configuration, if you see, they have general electronic configuration is general electronic configuration, GEC, is NH1. General electronic configuration is NH1. Outermost cell, valence cell contain 1 electrons. All having NH1 configuration. The alkali metals mainly, that is except hydrogen, These are the lithium, sodium, potassium, rubidium, cesium and francium. Atomic number 3, 11, 19, 37, then 55, then 87. So these are the alkali metals and their atomic number, and they have NS1 configuration. That is, lithium is, you can say, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. This is the configuration of outermost electronic configuration of that alkali metals, and before that noble gas configuration. For example, sodium, if you write sodium, sodium 11 can be written as neon 10, 3s1, like this you can write. Potassium, if you write potassium 19, that is argon 18, 4h1, like this we can write the electronic configuration. They have one electron in its outermost shell. They have single electron in their outermost shell. So they are monovalent. You can say they are monovalent. Valency 1, the combined capacity is 1. This is regarding electron configuration. Then atomic size. Atomic size. Atomic size, generally large atomic size, compared to other groups, they have large atomic size, and the order of atomic size generally lithium less than sodium, less than potassium, less than rubidium, cesium, francium. And francium generally radioactive nature. This francium is a radioactive nature. Generally, its property is not, it will not be studied with the alkali metals due to radioactive nature. This is the size, atomic size, very high atomic size compared to other. Why atomic size is high? Due to that no effective nuclear charge. Z effective, already know. Z effective is low. That is the question. Alkali metals, they have low Z effective. As low Z effective, so size increases. Z effective low means size increases. So that the screening effect is more, you can say screening effect is more, sigma value is more, high sigma value is more, high sigma value, that is shielding constant is more, because the inner shell opposes the attraction between nucleus and the outermost electron. That's why they have large size. So this is regarding. And smallest among these alkali metals, lithium is the smallest alkali metals. Then ionization energy. Ionization energy. Ionization energy, if you discuss generally low ionization energy, they have low ionization energy compared to other metals. Compared to other metals, alkali metals have low ionization energy. If you compare the ionization energy, that lithium greater than sodium, greater than potassium, greater than rubidium, greater than cesium. Francium is not required to include in this group because it is radioactive nature. So this is the order: lithium, sodium, potassium, rubidium, cesium. This is the ionization energy required to remove the electrons. As they have single electron in their outermost shell, so they can easily lose electron. That's why if you compare ionization energy, first ionization energy of this alkali metal is very low compared to second ionization energy. Is very important. The first ionization energy of alkali metal is very low compared to second ionization energy. Generally they have low ionization energy, but if you compare the first ionization energy and second ionization energy of alkali metal, the same alkali metals, I1 of that is for any alkali metal is very less compared to second ionization energy. For examples, for lithium I1 is 520 kilojoule, but I2 of lithium is very high, that is 7298 kilojoule. You see, compared to first ionization energy and second ionization energy of the same metal is very high. The difference is much more. Why? Because as they have single electron in their outer shell, they have high tendency to lose this single electron. But after losing this single electron, they will attain noble gas configuration. Sodium will be neon, potassium will be argon, lithium will be helium, like this. After losing single electrons, as they are attaining the noble gas configuration, to remove the next electron, that is second electron, required very high energy. That's why I1 is 524 kilojoule for lithium, but I2 of lithium is 7298 kilojoule. Very much more difference. So you have to remember the difference is very high. Then if you compare with alkaline earth metal, ionization energy of group 1 that is alkali metal is less than ionization energy of that group 2. But which ionization energy? First ionization energy. First ionization energy of group 1 is less than first ionization energy of group 2. But if you consider the second ionization energy, I2 of group 1 is much more greater than I2 of group 2. This is very important. This data is very important. Comparison that first ionization energy of group 1 alkali metals less than the first ionization energy of group 2. In the same case, if second ionization energy of group 1 is much more greater than the second ionization of group 2, because after losing the first electron, the alkali metal attain noble gas configuration. But after losing the first electron from group 2, it becomes like alkali metals. The configuration like alkali metals. That's why second ionization energy of group 2 elements is less than the second ionization energy of group 1. So very important, this one you have to remember this comparison. Okay, this is regarding ionization energy. Then electronegativity. Electronegativity, you can say electron affinity. If you could take both, they have low value. Both electronegativity also low and electron affinity also low, because they have tendency to lose electron. They have no tendency to gain electron. As they have little bit tendency to accept electron, under condition they may accept electron. That's why the electronegativity is low and electron affinity also low. But electron affinity of generally alkali metals considered as zero value. So very low electronegativity and electron affinity. If you compare, lithium will be greater than sodium, greater than potassium, greater than aluminum, greater than cesium. Because small size, compare means more electronegativity and a high electron affinity. So remember this. This is not important in case of alkali metal combining electronegativity and electron affinity. Then next property is that hydration enthalpy. Hydration enthalpy generally they compared to other they have low hydration enthalpy, but hydration enthalpy generally as the particular ions are after losing electron they are sulfated, highly sulfated. Maximum extent they will be sulfated after losing electron because the cation monovalent cation is more stable. That's why hydration enthalpy generally it depends upon size of the ions. As their large size, hydration enthalpy is low. But if you compare the hydration enthalpy, lithium has high hydration enthalpy, then sodium, then potassium, then rubidium, then cesium. Rubidium, then cesium. So lithium, sodium, potassium, rubidium, cesium. So this is the concept of hydration enthalpy. But lithium has very high hydration enthalpy. Lithium has very hydration enthalpy due to small size. Our size of lithium is very small, that's why high hydration enthalpy. Due to high hydration enthalpy, they produce in hydrated form, in salt form. Lithium chloride exists in hydrated form. That is, it takes 2 water molecules. Due to high hydration enthalpy, these halides of lithium chloride exists in dihydrated form. It takes 2 water molecules. Due to small size, more hydration enthalpy. Due to this high hydration enthalpy, it has also more negative value of reduction potential. We will discuss later this one. So this is regarding hydration enthalpy. Due to this hydration enthalpy, if you compare the size also, this is very important. Hydration enthalpy and size. Size, if you compare size, lithium ion is smaller than sodium ion, smaller than potassium ion, like this. This is in vapor stage. But lithium ion will be greater than sodium ion, greater than potassium ion. And this is the aqueous stage. In aqueous medium, lithium ion has large size. This is very important. You have to compare this thing. Lithium ion has large size in aqueous medium due to high hydration enthalpy. As it has high hydration enthalpy, as it is small size, generally Li plus is small size, but due to small size, high charge density, it accumulate or more number water molecule accumulate around lithium ion due to small size, more charge density. That's why hydrated lithium ions, this is the hydrated ion. Hydrated ions size decreases because when size will be small, more number of water molecules accumulate on the atoms, on the ions. That's why this is the difference between vapor phase ion size, ionic size, and aqueous phase, that is hydrated forms, the atomic size. Remember, this is also very important. That hydration enthalpy discussed, then oxidation state. Oxidation state, oxidation number, generally they shows M plus state. Always gives M plus state because having single electron in their outermost state. And M plus is more stable. And more stable also in M plus state. Because after losing single electron, they attain what? Stable electronic configuration. That's why M plus of alkali metal is more stable and they shows only +1 oxidation state. Then metallic in nature. Metallic in nature. Metallic, generally alkali metals are more metallic compared to other high metallic character. High metallic in nature. And generally metallic character decreases from lithium to cesium, lithium, sodium, potassium, rubidium and cesium. This is the metallic character order, increasing order. Due to increasing size, metallic character increases. Tendency to lose electron increases. And they are soft metal, and they can be cut with a knife. They can be cut with a knife due to soft nature. And if you see the density, if you compare the density, of this density order is that generally alkali metals low density compared to other metals, tension metals and lanthanum actinides, density is low, but density increases. Lithium less than sodium, less than potassium, less than rubidium, less than cesium. Why density increases? Because increasing mass is more than the increasing volume. Increasing mass is more than the increasing volume. No doubt mass is increasing and volume also increasing from top to bottom, but increasing mass is more compared to increasing volume. That's why density from top to bottom, from lithium to cesium increases. Okay? Then melting point and boiling point. Melting point and boiling point. Melting and boiling point generally low MP, low MP and BP. Melting point, boiling point is low. What is the order? You see, same. Lithium greater than sodium, greater than potassium, greater than rubidium, greater than cesium. Lithium, sodium, potassium, rubidium, cesium. So why the melting boiling point of lithium is maximum? Due to strong metallic bond. Small size, stronger metallic bond. Small size, smaller size, stronger metallic bond. Better close packing. Small size, better close packing, stronger metallic bond, high melting point, boiling point. This is the concept. Okay? Boiling point, melting point, density, metallic character. Then metallic character means highly electropositive character. This is also electropositive nature. Electropositive character. Electropositive nature. Same. Metallic character, electropositive character is same for the metals. Then another very important property shows that is flame test. This shows flame test. Means gives color on heating. On heating it gives color. That is flame test. When the flame test is will be carried in a particular test. So flame test, they impart different color in the flame. Generally lithium, why they shows flame test? Due to low ionization energy. This is the answer. Due to low ionization energy, they shows flame test. This is very important. Carefully remember why the alkali metal shows flame test, because they are chlorides. Their chlorides are more volatile. Chlorides are more volatile. Chlorides are more volatile and low ionization energy and chlorides are more volatile. Due to this, they shows flame test. So you have to remember these things. Okay. So what are the colors generally? Lithium color is crimson red. Lithium is crimson red and sodium golden yellow. Sodium golden yellow. Then potassium is your violet color, red. Potassium is pale violet color, and rubidium, that is red violet, rubidium red violet, and cesium blue color. So you have to remember the colors: lithium crimson red, sodium golden yellow, potassium pale violet, and rubidium red violet, and cesium blue. So they shows particular color on heating. That's why they can be identified. The salt can be qualitatively identified, qualitatively tested by flame test. Very important physical observation of alkali metal is flame test. By flame test means particular salt will be taken with the concentrated hydrochloric acid, then the mixture will be heated in the particular flame, then the salt will convert to chlorides. When it is touched to the concentrated hydrochloric acid, then salt will convert to chlorides. Then the chloride salt of alkali metals are highly volatile. They show different, they gives different color due to low ionization energy of the particular metals. Because due to large size, low ionization energy, the electron is easily excited. So the excited electron return to the ground state and imparting color. This is the main basic concept of flame test. So due to this flame test, we can identify the alkali metals. Then another important property, that photoelectric effect. This shows photoelectric effect. These alkali metals shows photo, because photoelectric effect means that electron can be ejected from the metal on heating. When it will be heated, then it ejects electron. It will remove electron from its surface. Which metal is better photoelectric effect? Potassium, cesium. Generally, potassium and cesium is the best metal for photoelectric effect, because due to large size, low ionization energy. Low ionization energy, one factor is low ionization energy and large size. That's why easily electron ejected from the metal surface on heating. That's why they shows photoelectric effect. Many alkali metal used as photoelectric materials, photoelectric cell. So potassium and cesium is the best materials for photoelectric cell. So these are some important properties Then you complete this one, then we will discuss other properties. Okay. Next property is reducing nature. Already know alkali metals has tendency to lose electron. The substance which loses electron is called as reducing agent. So as they have high tendency to lose electron, so they are the best reducing character. So better reducing character, reducing nature, high reducing nature compared to other metals due to low ionization energy. This is the main point. Then another thing, if you see the reducing character, generally lithium, if you see hydrogen enthalpy, if you compare the hydrogen enthalpy, if you compare the reducing character, generally reducing character mainly depends upon also hydrogen enthalpy, and better reducing nature due to first cause is due to low ionization energy, second is more negative reduction potential. They have more negative reduction. Almost all alkali metals have negative reduction potential. As the low negative reduction potential means high tendency to lose electron. That's why used as a reducing is very important property. More reduction potential is more negative means the reducing character will be more. Reduction potential is negative, but oxidation potential is positive. That's why high oxidation potential, better reducing agent, or low reduction potential also just opposite. So better reducing agent. So first is due to low ionization energy, second is more negative reduction potential. This is the first. Another exceptional behavior, exceptional character, exceptional nature of lithium. Lithium is the best reducing metal due to high hydrogen enthalpy. As it has high hydrogen enthalpy, resulting more negative reduction potential. As the reduction potential of lithium is much more negative compared to other alkali metals, that's why lithium is the best reducing agent. Reducing character of lithium is highest due to high hydrogen enthalpy and more negative reduction potential compared to other alkali metals. That's why lithium is the best reducing character. So we have to, if you compare the reducing character, we have to write like this. First is lithium, then cesium, then rubidium, then potassium, then sodium, like this. So lithium exceptional property. Although lithium should be least as per the size concept, but lithium has high tendency to lose electron when it is, because the aqueous medium, the hydrogen enthalpy is much more high. That's the reducing character of lithium it has. This is in aqueous, you can say aqueous medium, aqueous states. If you see in vapor phase order is cesium, then rubidium, then potassium, then sodium, then lithium in vapor phase. In vapor phase, if you take vapor phase, cesium will be highest because last side easily electron can be lost. But in aqueous medium, exceptionally lithium has maximum reducing character due to high hydration enthalpy due to small size and resulting more negative reduction potential. That's why exceptionally lithium is the best reducing agent. Okay, so these are some physical properties of alkali metal we discussed on today. So in the next class we will discuss the chemical properties. But one thing remember, all physical properties you read, every points you read and remember the concept, remember the principle, why the property changes, why increases, decreases, what is the cause. You have to remember in this way, what are the physical properties they show and what is its cause, what, by which principle, which concept we can explain these physical properties. Okay, thank you all.